Now let's talk a little bit about the basic force equation that what we have. We've talked about free body diagrams, we've talked about net force. Let's talk about the equation that we use for force. Now force equals mass times an acceleration. Now the force is a push or a pull on an object, but the equation that we use is force F equals ma. Now force is, we already said, it's the push or pull on an object. It's measured in newtons. Big thing here is measured in newtons. If it asks you, anytime it asks you about weight or it asks you about the force due to gravity, weight is never in kilograms. Weight is always in newtons. The other variables that we have, the m is going to represent mass. The mass is always going to be in kilograms. Okay, so our mass is going to be in kilograms. Our force is in newtons, and then our acceleration, which we know from our kinematics unit, is meters per second squared. Now, what we can see is that when you multiply kilograms per meter times meters per second squared, that is a unit. So if you see force represented as kilograms times meters all over a second squared, that is a newton as well. That is a force. One thing we need to make sure of is realize that that acceleration, can relate back to all of the kinematics equations that we learned in the previous unit.